So now, having looked at the resultant of forces, let's begin now analyzing different forms of forces. Now let's look at the parallel forces. Okay? How do we get the resultant of parallel forces? We have looked at interesting things that is something to do with the component. How do we get a component of a force and the process of getting it? And then after getting the component, we're saying that we can also get the resultant, isn't it? Now, after knowing how to get the component and then come to the resultant, can we now begin analyzing some of the types of forces, parallel forces? Parallel forces. So I can say, here we can just move direct to some simple example and see how we can get the resultant of the forces. So we can say, for parallel forces, the resultant can be obtained by getting the algebraic sums in a given direction. Example, I can talk about here an example. Find the resultant of the following forces shown below. So we can maybe, if we're looking at parallel forces, okay, I can look at something like this. These are now what we are calling parallel forces. Okay, this is part A, and then part B. We can also look at, you can just look at something very interesting here. And if I have this pulling that, and then you have this one as 7 newtons, and then you have this one as 4 newtons, and this is mica 1 newton. How do we now get the resultant of these parallel forces? Just a simple case for us to begin with, and then see what actually happens with this. Okay? We can now say, if we were to solve that, we can now look at so how do you get the resultant of these forces? Please, there is a note we looked at here that when we are solving forces, before doing any other thing, you should get the convention of the direction. Which direction will I take as a positive? Which direction will I take as a negative? So, if I'm dealing with this, I can see that all the forces are horizontal. And if we are having horizontal directions, we are aware that we have two things, a positive and a negative direction. What does that mean? That whichever force which is going the other direction should be taken as a negative. And whichever force that is going in the other direction should be taken as a positive. Okay? So that kind of convention is really very, very important you should keep it part of you as we are moving toward a more and a better complex example. So, how do we now solve this one? After knowing whichever force that is this side is the positive and the other side negative. And we said that we are just going to get, if they are parallel forces, we just get the algebraic sum of the forces in a given direction, but not forgetting the convention of the negativity and the positivity of the force. So here we can now say our resultant in X, okay, because it's a horizontal force, you can say summation of forces in X or resultant in X, we can now say is equivalent to this one that are going this side, I can call them positive, and then this one is also a positive, and then I have this one is also the other side should be a positive, and then this one is the only one going the other side, I can say it is a negative, okay? And then you can now try adding that. You say 2 plus 3, that is 5, and then 5 plus 6, that is 11, and then you subtract away 8, you will realize that you're having 3 newtons. But not forgetting that forces have direction, isn't it? So we can say the resultant force is 3 newton to the positive x direction. Okay? Or you can say to the right, isn't it? To the right or to the positive x direction. And then after solving that, we can also look at how do we analyze this kind of problem here. Still also a parallel force, but this is parallel in a way that it is in vertical direction, okay? All of them are in vertical direction. And then we can now say, we are also aware that if we talk about vertical direction, we have positive, okay? And again also we have the negative direction. And what does that mean to us, or how does it even help us? That if a force is moving down, basically we shall take it as a negative. And if a force is moving up, we shall take it as a positive. And our convention is that vertical direction, we can just represent them using y. It's just a convention. So we can say, if we look at forces in y, you say summation of forces in y. Another clean way of writing your convention, you say, I'm summing forces in y, but I will take whichever force that is going up as a positive. Okay? That one can also help you now, like also here you say summing forces in x. Isn't it? Forces in x. You write as a substitute there. And then I'm taking whichever thing that is going the other side as a positive. You can also write like that. You are allowed that I'm taking every force going that side as a positive and I'm going to sum them together. And then here I will get something to do with the up is a positive, and that is 7. Okay? 4 is down until the negative 1. So it's a minus the 4 newton. And then 1 is also down. I can also say minus 1 newton. And then I will say this is now 7 minus 4, that is 3, minus 1, that is 2. And then you'll come up with the 2 newtons. And then you also make your conclusion and say, therefore, the resultant is 2 newtons in the positive y direction. So this is how now you can handle simple problems of parallel forces as we are getting ready to non-parallel forces, which can either be 2 or more, or can also be only 2 forces acting on the body. Thank you.